And thank you everyone for joining us today for Graph Gurus 53, Visual Insights with Graph Analytics, Tableau, and TigerGraph. We will be starting in just a minute. Okay, thank you. Thank you everyone for joining us today for Graph Gurus 53, Visual Insights with Graph Analytics, Tableau, and TigerGraph. Just some housekeeping tips before we begin. Your device is muted. You can ask questions at any time by using the Q&A feature in Zoom. You should see that in your menu at the bottom. So yeah, we'd prefer if you ask questions through Q&A. There's also a chat feature, and that is for chat. So the real product questions, if you can save those for the end, we will be answering. We'll have a Q&A at the end. But if you have any Zoom problems, you can also try to submit those, and we'll see if we can help you out. And this is being recorded, so you will we'll send you a link to the recording as soon as we're done. I'm Victor Lee. I'm head of product strategy and developer relations at TigerGraph, and I've just passed my 6-year anniversary at TigerGraph. I'm really excited to be joined today by Rob Horton, our senior sales engineer. He comes to us with 20 years of experience in the business intelligence and data warehousing sectors. So I'm going to be sort of the TigerGraph graph expert, and he's got both the TigerGraph and the BI knowledge. And it just turns out that we are both in the great state of Ohio. So this is our agenda for today. I'm going to start off talking about TigerGraph and connected data analytics, and a little bit about Tableau and what it adds to the equation, the power of visualization. And then how we've connected the two with a new connector and by offering some SQL language support. And then Rob is going to demo the two together. So talking about advanced analytics and machine learning on connected data, we sort of have this 3-phase or 3-aspect description. You can connect, analyze, and learn. So the great thing about graphs is they let you very easily, very intuitively, and very performatively connect all your data. You break down, taking just even one data source and expressing it in a different way to really highlight how things are connected and related to one another. And then it becomes really easy to bring in additional data sources, breaking down your data silos, bringing in all the data from the different parts of your business, merging internal and external data sources so you can get a holistic view, what we often call a customer 360, or it could be a product 360, or whatever entity that is of interest to you, to get a really comprehensive 360-degree view. Having all that information and seeing how things relate to one another is really the power to answer questions that you otherwise would not have been able to. You can obviously model supply chains and social networks. They look like graphs when you think about it, but you can also do finance, very transactional things, or products and services, cybersecurity. The list of applications goes on and on. So you can start off by answering straightforward questions to just inspect your data and learn about your data, explore it. But then you get into the much more analytical phase. And this is where TigerGraph's distributed parallel computation with built-in aggregation becomes really important to be able to performatively do that analytics. So understand, what is happening in my business, to really characterize it, to look deeply, to follow multiple connections within the graph, to do that deep investigation, identify bottlenecks and weak spots, to do optimization, to set up alerts, look for particular patterns. So, and that's sort of the key with fraud analytics. Fraud follows a certain connectional pattern. So you search for that pattern, and if you see it anywhere, that's an alert. Maybe you block the transaction, maybe it requires further investigation. And then you can start to make predictions, and that's where machine learning comes in. So from these patterns, you start to be able to understand the data and develop models of, you understand what is fraud. You understand from patterns how to make a recommendation. You know, it's user specific, it's data specific. You know, suggest things that other people like them. So if you can understand what is a similar people that have similar taste, it's not a set of rules, it's not pre-programmed, but it's using machine learning to look at your data and sort of see case by sort of what is the characteristic model pattern within your data. And you can use that to either, you know, improve your sales by, say, recommendation, or you can, you know, reduce costs by optimizing operations, reducing waste, or you can reduce risk by, you know, avoiding risky cases, you know, eliminating fraud, et cetera. So it's a very powerful tool. You know, here's a graph. There's a very simple graph where I just have one product order, which, you know, you notify the supplier that maybe it's low on stock. It's shipping from a certain location to another location. It was purchased by a particular customer. So the key thing you see here is not only do you have these entities, but you have these different relationships, which are named. And so it's very intuitive. It's an easy, intuitive data model. And you can see how you can connect data from multiple sources. I may have a whole supplier database out here, and I can connect things from that. You can start to ask questions which, you know, seeing the semantic names of these relationships, it's very easy to form questions in your mind, and you can go several levels deep. One of the things you sort of learn after you work with graph is understanding that you can, here's one person, or excuse me, one person, but it symbolically represents multiple people, because there's this looping relationship. And so you can ask, do you know anyone else who has bought this product and, you know, maybe has written a review and recommends it? And you can do social recommendation in that way. You can start to run graph algorithms. That's something that I studied in grad school. It's an area of sort of particular interest for me. You can do graph enhanced machine learning. And once that machine learning, because it is based on these semantic descriptions, it produces very explainable results. And so that's one of the challenges with modern deep learning, that it does a great job, but sometimes the results, the models it produces are not very explainable because it's using these synthetic hidden features, which don't surface in the data that you and I see. It's these sort of artificial variables that were created by the model. If you do machine learning, not deep learning, but other types of machine learning, which work perfectly fine, and you retain these semantic links through your training, then your result will retain that semantic description. And then lastly, of course, you get the visual display. You know, we can just, you don't have to be a data scientist or a computer scientist to look at a graph and understand what it's saying. Some of the real world use cases, I'm going to go speed up a little bit. We have customers in healthcare. One of them has built a 1.3 terabyte graph brain, which it uses for real-time care recommendations. Those real-time recommendations, they not only improve healthcare, but they, of course, lower costs. They save the healthcare providers and insurance companies money, and they save the patients money. Industrial supply chain. If you draw out a supply chain, it's pretty obvious that it's a graph, and there are existing supply chain management tools. But to really do again, the deeper analytics to integrate all your data and to make strategic decisions, not just to kind of monitor how things are going and to make the more obvious decisions, but to really take a step back and saying, are we even doing the right things here? One of our customers, Jaguar Land Rover, one of its key strategic decision-making analytics took 3 weeks before it adopted TigerGraph. It then now only takes about 30 to 45 minutes. That is transformational. A 3-week analysis is basically non-functional. Something that you can do in 30 to 45 minutes, you can run several iterations in a day, and you can really make real decisions. So that's so transformational. They expect to save $100 million a year. And lastly, financial services, real-time fraud detection. As I said earlier, you can see the pattern of fraud visually. One of our customers, again, says using Graph enabled it to integrate multiple tools, multiple operations that it wanted to do. It can now do from this one platform. And the way that it enables this very natural visualization is magical. And, you know, again, some fraud is automatically rejected. Other cases require investigators to look, or, you know, even if you did reject that transaction, there may be law enforcement follow-up. And so somebody has to actually look at that data, and the very visual display of Graph, again, is transformational. So taking a little bit more look at healthcare, I've done this presentation before talking about this particular use case, so I'm going to go over this very quickly, just saying that in a healthcare environment, you might want to find, or many environments, you might want to use PageRank graph algorithm to rank each service provider in a network based on referrals. So the one who gets the most referrals, not just the most, but the most influential referrals. And then you can also use another graph algorithm to understand communities of providers that work together. Some other healthcare questions: finding similar patients who have similar personal characteristics, sort of similar demographics, similar age, gender, and then similar health history, and similar interaction with the healthcare system. To try to record all that in a tabular database would be not only awkward, but almost impossible, because the very evolutionary nature of all those services, you know, the data is constantly changing, the new relationships are coming up all the time. So you can then use a graph to help you make a diagnosis based on the patterns you see. You can make recommendations for treatments or next step, like our customer is doing, and you can start to group things by their similarity of situation. And it's very, not necessarily by direct connections, like these 3 persons in the center of each of these clusters, those 3 persons are related because they reside in similar situations. They're not directly connected to one another. They don't know each other, but they have similar profiles. Switching to the supply chain use case, Jaguar Land Rover, they wrote in a report, which was, or Gartner actually investigated their case study, and Gartner wrote a report. And the way that Jaguar Land Rover describes it is you can sort of conceptually talk about their data in different tiers of the car tier, features, parts, and suppliers, and things. You can see how the things move from bottom to top, eventually producing cars, and that, you know, they can investigate both up and down the hierarchy to consider both demand and supply. And, you know, this ability to investigate either down the chain towards the car or back up the chain towards supplier, to look over time, to look over you know, different geographic distribution, to add in contractual constraints, purchase agreements, not only what is available, but how much will it cost, how long will it take. Adding in all those constraints is a very difficult mathematical analysis. To do it with traditional matrix, linear mathematics would be, again, very, very difficult. Doing it in the graph way, it becomes much more tractable, much easier, more efficient. And while this is the auto industry, you've probably heard, when you've heard about supply chain over the past year, as things shut down at the beginning of the COVID-19 pandemic, how that impacted supply of things everywhere, and then demand changed. Delivery for certain services greatly increased. So things were disrupted in ways we have not seen in our lifetimes, probably not since World War II, have things so radically changed. Somehow businesses adopted. Some did better than others. Those that had efficient analytics that could quickly analyze a completely different situation did much better. Now I'm going to talk about Tableau for about the next 10 minutes, and then I'm going to hand it over to Rob. So we've got this beautiful system for doing advanced analytics efficiently and in a very understandable way using graph. The thing is, to understand the results, you don't always need to see those nodes and connections, sticks and balls, as we sometimes call them, the edges and nodes. What you might need to see is, how is my business doing? It's great that I have this analytics, but what your business leaders need to see is a dashboard like this. And that's where a business intelligence tool like Tableau is so important, so powerful. They enable anyone. You don't have to be a technologist. So whatever department you work in, if you can use Excel, you can use this. You can explore your data. You can dig into it to discover, analyze, measure, etc. It says any data. You can connect, combine, catalog, and we'll come back to that any data. And then anywhere, they're now Tableau and its competitors, and we'll talk about this is a whole market space. We're here to focus on Tableau today, but this is a whole domain, and TigerGraph is addressing that whole domain. They're now available on-prem as originally on the cloud, mobile, embedded. So it's really doing it where you are. Now, the thing about any data, the name of the company, Tableau, kind of says it, table. It's expecting data is in table. That's the way people traditionally have organized their data. What they're allowing you to do is to very intuitively dig into that table, and maybe multiple tables. And if you can sort of establish the relationship between those tables, i.e. a join, then just like in a SQL relational database, you can explore it. So the secret, if you didn't know, is what's happening on the back end of Tableau is it's submitting SQL queries to the data source. So if the data source is tabular, and if it understands SQL, you're in great shape. And even today, a lot of NoSQL databases will accept SQL. So, they've sort of seen the market demand that even though internally they are not structured the same way as a relational database, but to make the querying capability available to as many people as possible, they often support SQL. Now, again, this is just the Jaguar Land Rover use case. They're a customer of TigerGraph's. They're also a customer of Tableau's. Their CEO, Jaguar Land Rover, requested that all the executive reports be done using Tableau. And within 9 months, they had shifted to 7 out of 10 business units were using Tableau, made a big shift very efficiently, and it's saving them tens of millions of dollars or pounds, I suppose. They're getting better information. They're sharing information across the company much better, and they've enabled really data-driven decision-making. Their head of corporate analytics program Clive Benford, said, "The beauty of Tableau is how the visualizations help close the gap between the analyst and the end user so that analytics energy is focused on what analytics to do, not how." Now, oops, I thought I had redrawn this, but I was going to show you just the left half first, but you see both halves. So here's a graph view I showed you. The thing is, I said, BI tools need to see a tabular view. So it's a pretty simple transformation. You can gather all your payment vertices, and if you think of them being listed out as, you know, here's a payment ID and here are all its properties, and you list another, here's another payment ID and all its properties, you've got a table. You do that for each vertex type, you then get a table. So there's a payment table, there's a supplier table, etc. Second, you do the same thing for each edge type. So a customer makes a payment, that is recording in a ledger table. So I've got a list of payment. It's not the payment itself, it's the event of making the payment. So these probably have dates assigned to them, perhaps. You know, the knows this is going to be, this table is going to have 2 customer IDs. This customer knows that customer. So this table, customer table, is listing individual customers. This table is listing who knows whom. So I've got 2 types of tables, vertex tables and edge tables. And then, so you can see how we can do a simple transformation in the schema. This is sort of pseudo GSQL. I abbreviated it to keep it simple, but basically I define the vertex customer type, I define the location vertex type, and I define the resides directed edge. Notice I have a ID there, an ID, and I have a pair of IDs because this edge goes from a customer to a location. Here is how you would write it in SQL. We just call them all tables. I can still use the same names, though I might, for clarity, I might want to change this name to customer resides location. But to keep it short, I just called it resides. And notice we're now using the same primary keys. So there's CID, LID, and the pair. So here we have a composite primary key. So that's a very straightforward transformation. And then there's also some more additional transformation for the queries, taking a SQL query and transforming it to a GSQL query. Now I'm going to stop here and have my disclaimer. I'm not saying that we now support the entire SQL language. I wish I could say that. We are doing work in that area, so stay tuned. But what we do have now is the basic support that what sort of SQL queries would a tool like Tableau submit. So it's a more limited excuse me, use of the language. And so what we do have today is that basic support for select statements and certain, basic inner joins and some other syntax that you would find. So we did work on our side. Tableau added this, so basically presenting a SQL view of our graph database. And then to help us with the connectors themselves, we partnered with one of the leading companies for database connection, CData. And so they actually developed 4 things for us: a Tableau driver, a Microsoft Power BI driver, a general JDBC connector for if you are a data consumer here, if you're trying to read data from TigerGraph, and also an ODBC driver. And if you go to the CData website, you'll see the many potential applications this has. So I've used up my time. I'm going to switch it over and let Rob present to you now.
Thanks, Victor. So let me know if you cannot see my screen now, but let's start in TigerGraph. This is our development environment, which we call Graph Studio. We design, we load, we explore, and we query our graphs all from this environment. And our graph today, for purposes of our demo, is called HC Healthcare Referral. And it contains, if I go to design schema here, we can see that it contains prescribers, patients, claims, and some specialty and subspecialty information. The focus of our demo today, though, will be on this referral linkage that we see over here. Before we go too deeply into that, just a little intro to graph and how it compares to a relational database. Like Victor said, we see the circles, which we call vertices, a vertex. We can refer to it as a node as well. These are a lot like relational tables. We also see the relationships between them in a graph. These are called edges, and they're just as important as the vertices. I really like that the way the data model and graphical results kind of self-document in a graph. We can see that patients have claims. Claims are submitted by prescribers. Prescribers have subspecialties and specialties. If you're an experienced person, data person who's worked with RDBMSs quite a bit, relational databases, you'll immediately recognize that this referral join here is it's kind of the back when I was working a lot with this, it was kind of a thorn in my side, the dreaded self join. It's a typical parent-child type of relationship. And in this case, though, we can have a many-to-many relationship. As far as referrals go, prescribers can technically refer patients to any other prescriber at any time. We don't know where the referral chain starts and where it ends, and that makes things typically difficult to query in a relational database. Now, if I hover over this, we can see some of the attributes associated with it, kind of like columns in a relational database. But one thing that we've done with this data is we've already enriched it by running some complex graph algorithms on top of it. One of those is PageRank, which we run to determine how influential a particular prescriber is. We'll talk more about this when we show it to you in Tableau, but the output of our algorithm is a score for each prescriber, which we, in this case, are calling PageRank. The other algorithm that we ran is a Louvain community detection algorithm. We look at each prescriber and all of their connections and determine a virtual community of similar entities. We generated this as community ID, and we'll show that how that's used in the demo as well. So, but the point is, these both of these algorithms would be very difficult, if not impossible, to run directly from Tableau to get that kind of result. So we can do some heavy lifting here on the graph side before we go into presentation mode in Tableau. If we look at how we map data into our graph, we see that we're loading both our vertices and edges. In an RDBMS, of course, you don't load data into a join, they just happen at query time. This is kind of the secret sauce of graph. It enables TigerGraph to do very complex processes in milliseconds that would consume minutes, hours, or even be impossible to operationalize in a relational database. If we continue on down here, if we go to our load data tab, we can see that we don't have a super huge data set in our demo today. Look over to the right, we see we've got about 11K on the vertex count and edges about 20,000. Not a real big data set. We have lots of publicly available graphs on our test drive site where you can perform queries against billions of entities and see that comes back in just milliseconds. Let's do a quick exploration of our graph. Just look at some of the data that's in here. Now, let me back this off a little bit. Let's start at the beginning. And let's look for maybe a particular prescriber. I know that I have a prescriber out there that's, the name of him is Pre16. This is obviously not a real name. So I can bring that up on my exploration panel here. And let's start to take it to a deeper level. And what I'd like to see is some of the information on what's related to Pre16. So I really want to focus on what's who they've referred and what that network looks like. So I'm just going to focus on the referral relationships, and I just want to show other prescribers. So I'm not going to see all the claims that Pre-16 has submitted or anything like that. We'll focus just on the referral relationships. Now, when this comes back, it looks kind of chaotic at first, but we've got the ability to use our little widget here to force it to a more viewable view. And what we see in the middle now is this Pre-16 prescriber that we started with. We see what his community ID was, his name, and his PageRank score. But we can also see that these other prescribers that he has referred patients to, we can see there's 8 different ones of those, and they've got claims that they have submitted. So this is kind of the start of, kind of just exploring the graph and kind of clicking around and going through, and you can double click on any of these and see what else makes them up. If I take a particular claim here and double click it, you can see, that it's related to a particular patient. We could go down that route. Now, so this is just kind of a development environment, right? It's not one where we would, where we expect a lot of end users to have access to this. This is more the dev side. And what happens is a lot of our customers, they'll write queries that can be executed in a variety of ways. So what I want to do is go over to the write queries area and just show you, some of the complex ones that we've done. Now some of what you see here are the algorithms that we ran. Here's our algorithm for PageRank, our algorithm for community detection, where we use the Levain technique. So, but what we want to do here is look at my community for a particular user, and we'll focus on that Pre-16 as well. So we can see that we can navigate in less than 20 lines of code. We can take a particular prescriber, see everybody that they have recommended and referred, or to other patients too. We can also see everyone in their particular community ID that we generated earlier and what they've generated. So that's actually the results we're seeing down below, but I'll just show you how we ran it. We just type in their ID. I want to see their particular network. So when I run this, that's what shows up here. So what we see is everyone that's in the community ID with Pre-16 and who they've recommended to. Now we have a couple here that have actually recommended to each other, right? Pre-36 and Pre-8, there's referrals going both ways. So to get this type of result and display it in in a typical tabular format would be a challenge. But this is the kind of thing that TigerGraph does very well. Now we can also take these results and just view them as a JSON result, which is a little more tabular than the graphical view we saw. So we can export this JSON and really bring it into any tool for display there. So this is just a quick introduction to TigerGraph and this data model that we're going to be using to query, and it's actually a live query against this it's this particular data set that we've set up from our Tableau environment. So let's begin at the beginning of our integration with Tableau and TigerGraph. So here we are in Tableau now. And just like any other data source in Tableau, we begin by connecting to the data. Now, this should look familiar too if you're a Tableau user. So I've got lots of different data sources over here on the right, but since I've recently connected to TigerGraph, it shows up in my list here. So I'll just choose TigerGraph by CData. Victor talked about our relationship with CData on this. And it asked me for my TigerGraph credentials and the server that TigerGraph is running on. And that's the same one that we just saw my interface running on. So if I put my password in correctly, in successfully, and then key it in, then it will take me to the next step in Tableau. So looks like it all worked. And so it gives me a list of schemas. So these schemas correspond to different graphs Now on a particular TigerGraph server, I could have multiple graphs out there. On mine, I only had the one called HC referral. So we're going to start there. And when I click on that, down below, it shows me what we would normally see all of our tables and views. But for TigerGraph, what we see are all our vertices and edges. Now let's begin to build our data model, or as it's called in Tableau, a data source, which can be shared later on with other users. So this is kind of the part of the heavy lifting of the interface that not every end user is going to need to do. This is something the person who sets up the data source would do this part, and it's the part I think that we need to focus on a little bit today because it's a little different from a typical relational source. So let's start with prescriber and just drag that out onto our palette here. So I can do an update now, which will just show me the data that's in there. Okay, easy enough to do. So now what we want to do, remember, we're kind of emulating this particular data, the view of the data, right? So we've got prescribers, claims, and so forth, but between them, we've got these edges. We got subspecialties prescriber, we got submitted claims, and we've got the referral relationship as well. So let's go back to Tableau and notice I've got these, it looks like a table in Tableau, but it's called claims submitted prescriber. Well, what this actually is a view, a name, the way we've generated the name of the edge. So the beginning and the end are the two vertices that are being connected, claim and patient, and the middle is the name of the edge. So if we look back here, between like claim and patient, I've got claim, patient, and between that, I've got claim dash patient as the name of the edge. So that's the naming convention that we see here. So let's stick with prescriber for now. Let's drag claim submitted prescriber over to our data model. And what it wants us to do is define the relationship. This part could be a little confusing. So I really want to make sure that you understand what we're doing here. So the key point here to remember is whenever you're dealing with a relationship, whenever you're starting with, on the left here, we've got a what we refer to as a vertex that's connecting to an edge. On the vertex side, you'll see something called VID. That's an internal ID that TigerGraph uses to connect things together very quickly. And then actually on the edge side of this relationship, what we want to do is choose the ID that corresponds to whatever we're linking to. In this case, see how we're linking from prescriber to this particular edge. Well, we want to do VID on the prescriber side, and we want to do prescriber ID on the edge side. So whenever you have a vertex, remember the VID will be one of the attributes. So you want to choose that as your connection, as your relationship. So now we would just hit close and close that and just kind of double check it there. So we see how this is built out. Okay, so let's go a little further. Let's now we started with, we did prescriber and then we did claim submitted prescriber. Well, let's put claims out here now. Claims would go on the other side of this relationship, right? So in this case, now on the left, we've got what? We've got our edge, which has claims and prescribers. It's the relationship between those two types of entities. Well, on the right here, we've got all of our claim related information, but we've also, remember, we've got VID, which in this case points to claim. So we want to choose VID there and claim ID here. So we close that out, and that's how we start to build this out. So let's go a little bit further along the prescriber view here. Let's expand this a little bit. And let's go from maybe prescriber to subspecialty. I drag this out here, see how they're kind of parallel. Again, I'm starting with VID on the prescriber side, and I'm choosing prescriber ID on the edge side. And I hit close. Okay, so it's getting pretty simple to build out. Let's do one more step here and pull in subspecialty. That's the thing we're joining together with prescriber. So we've got on the subspecialty side, we want to choose VID, and on the relationship side now, we want to choose whatever we're connecting to here, which happens to be subspecialty on this side. Okay, so let me know in the chat if you have any questions about this. Victor will answer them as we go along. So let me just do one more of these. I'm not going to build out this entire data model in front of you here, but I wanted to just see enough of it to see what we're doing. So let's do next the prescriber referral. Remember, the referral actually did a join back into itself, right? So this might be a little confusing, this self join. So let's finish this out. So again, I'm on the prescriber side. I choose VID, the internal ID there. And what we want to do in this case, now I've got the from prescriber ID and the to prescriber ID. Well, we're starting with the person who is doing the referral. So that would be the from prescriber ID. Then I hit close and close that again. And then to finish this out, since it's a self join, what we're going to do is drag this over here, and Tableau will create an alias for us. So now we see it's called prescriber one over there, but it's really the same table, just being the same vertex being aliased here within Tableau in the data source definition. But in this case, we want to start with the to prescriber ID, and we want to choose the VID of prescriber one. Okay, so that's how we would accomplish this this self join, and we'll actually use this as we go through. All right, so let's continue on here. Let me kind of do the old cakes already baked kind of demo here for you. So I built part of the data model as we went through, but here's the completed version of that. So what I want to do is use this now to actually show you some of the presentation capabilities that Tableau offers related to TigerGraph. So let's go to, I've got a tab here, prescriber referral network, but I've got nothing on it yet. So let's do some actual reporting. This is going to be live against that same database that we were working with. So we're going to start with prescribers. Easiest thing to do, start with name. Let's drag that up and make it our row here in Tableau. If we can see, I've got a couple that are actual names. The rest of them are just kind of codes there. I've got lots of those out there. Now, what I want to see is maybe I'm a marketer getting for a large pharmaceutical company, and I want to market to the prescribers who are the most influential. I don't want to give it to some. I don't want to market to somebody who never necessarily refers anybody to anybody else. I want to really hit the influencers. So we've got that page rank that we defined earlier. But if we didn't have TigerGraph, we'd kind of just be saying, okay, well, who refers the most people? Well, that would be just we would just start there with referral count. So on our relationship prescriber referral, we drag that over in make it our column there, and we can see that it just gives it to us in a bar chart kind of automatic format. And if I highlight this and do a sort on this, now it's sorted by who did the most referrals. So we see that pre-2 did the most referrals to the most different other prescribers with 9. They've referred to 9 others. Well, does that mean they're the most influential? Maybe, maybe not. What we want to do now is look at our page rank that we defined earlier, which is the score on that not only looks at how many referrals you've made, but it also looks at what kind of influence does the people you've referred to, what kind of influence do they have, and so forth. So it's kind of how you determine the most important websites in a search engine. In this case, we're determining the most important prescribers, and then we're using that particular algorithm to do that. So if we sort it by page rank instead, we can see that this pre-16 has the highest page rank of 2.7. And if we scroll down, remember we had pre-2, I think, was the one who had the most, and they're way down the list. There's pre-2 right there. They've got the most actual referrals. You see the long bar here, but the people that they're referring to, that's not a very influential network. So it would probably make more sense to, as a marketer, to attack those who have the higher influence score. We can take this a step further and see for the people that I've actually referred, which prescriber has, for the people that they referred, which of those people have the highest average page rank. So which prescriber refers to those who have the most influence. It's like if I influence, if my it'd be like the influence that maybe Elon Musk's father would have. By himself, maybe he's only making one recommendation, but he influences Elon Musk, who influences millions. So it's kind of that type of mindset. So we can take that a step further and see the score of the folks that they have prescribed to, and we take that up to our column area, and instead of a sum, let's make this an average, because multiple users would be included in this particular calculation. So now let's look at this and calculate it this way. So this would be who influences the most, who refers to the most influential people. Well, that's now pre-4. So pre-4, the people that they prescribe, that they refer to, have a page rank score of 2.7. Now pre-4, theirs is only 1.3, because they really only refer to one person, but that person happens to be the most influential person out there. So that's where these different numbers come from. So that's kind of a quick look at it here in Tableau. Now we can also use Tableau to get some nicer views of this. So let's just play around with that a little bit with our visualization. So if we take count, maybe drag it down to size, and if we turn our page ranks into the X and Y axis, now we see, based upon the size of the dot, that's actually how many others they have referred, but based upon their placement in the chart here, that's how their page rank stacks up. So if we look at this one pre-16, who was the most influential, we can see they prescribed, or they refer to two different other prescribers, and those have a page rank of 2.1, but their own individual page rank is 2.7. So we can take this a step further and segregate this by our community ID. Remember, we looked at that over on the TigerGraph side, where we've looked at all the prescribers here and done a virtual grouping of them into something called community ID. So if I just take community ID over from my prescriber, drag it out onto the color area, now we see that the different that different, if I click on one of these, we can see it highlights those that are in a particular group, in a particular community. So we can see their influence there as well. So that's really what I wanted to show you from the TigerGraph to the Tableau side. Let us know what questions you might have about this. Thanks.
Thank you, Rob. I am going to finish up. Let's see, hopefully I'm showing the right screen. Give me 1 second. There we go. Hopefully are you seeing that availability? Yes. So the connector is available. The support for the Tableau and the other connectors I talked about, Power BI, are available starting in TigerGraph version 3.1.2, which we released about 3 weeks ago. So if you have an older version, you need to upgrade. And it's currently available for people who download the product or run it in Docker. It will be coming to TigerGraph Cloud in the very near future in a couple weeks. The cloud's about 1 version behind. It's at 3.1.1 currently. The connector as a beta version is available free, and you can download it from our partner CData. We'll have the link in the next slide, but you can just go to CData and look for drivers, and Tableau were listed right there. Currently, it works with our interpreted queries. So just as Rob was showing you, he was building up queries as he went and just ran them instantly, which is the way that a developer expects them to work. And it currently works with single server deployments. So if you have a single TigerGraph instance like he had, it works fine. And the level of SQL support, as I mentioned, is focused on what is used by tools like Tableau and Power BI. We're not yet claiming full support for SQL 92 or SQL 99. It is limited. We are working on additional SQL support. So in our upcoming product versions of the database itself, so not connector updates, but product database updates, we'll have support for installed or compiled queries, which we can run it as in the same way that you would run SQL stored procedures. And we'll also have support for distributed graphs. We know that's a key feature for TigerGraph, that we are a distributed graph. So naturally, we want to offer that. So look for updates to the TigerGraph where we'll have that further support. So wrapping up, what we've done, we've talked about graph analytics being the best way to process and analyze connected data at scale. Whereas BI tools enable anyone to visually analyze, and to gain insight from tabular data, this connector that we now have, it breaks down the separation between the two so that you can get the best of both worlds. Sorry. So we invite you to go and try it. I said, you can go to our developers.tigergraph.com to see about our full ecosystem of offerings. This is now listed as just one of the many connections and integrations we have. You can go to the CData website, drivers and TigerGraph, and download it. And I want to thank you again for your time. And we do have a few questions. So, and I think we will get to those right now. And let's see. I think here's one for I think Rob answered it online, but want to make sure everyone sees this. Does this work with just the cloud version of Tableau or with Tableau Server? And Rob's answer was, we use Tableau Desktop for this. So it's designed for Tableau Desktop. And again, he had the developer or creator license so that he could create a data source. And once the data source is set up, then just sort of creating a dashboard you can have a less expensive Tableau license, and just to use a dashboard that somebody else has developed, is even the more basic Tableau license. The connector itself, we're offering for free. There was another question in the Q&A. How are edges different from foreign keys in a relational database? And I want to go back in the slides to this, maybe here. I'm not sure if this is the best demonstration. So what we have here is I've got 2 vertices and 1 edge. And over here, I have 3 tables and sort of a pair. I didn't explicitly state it, but you can sort of imply that there's a, foreign key to primary key relationship here, foreign key to primary key relationship there. This is 3 entities. In edge, we translate to another type of table. The difference conceptually, they kind of serve the same function, but the difference in implementation really goes to why graphs follow connections, do hops more efficiently than relational databases. And I want to spend a minute to explain this, because even though I've studied relational for, I worked with them before I worked with graph, it actually took me a little while to realize this. Each of these is a column. So even though when we say that this is a foreign, this is a foreign key referring to that primary key, they're 2 separate columns which exist in separate tables. And the relationship means we enforce referential integrity. It means that any value that I put in here should already exist as a value over here. So that's a constraint or a check that the database performs every time you insert or update this value. But there is no actual existing match between any particular row in this table to any particular row in that table. When you do a join, then it has to go find those matches. That's the difference. In a graph, what this really is this is really a pointer more, and the match actually exists already. And because the matches are at the individual level, it's saying there's an individual edge that matches to this individual customer, and it's actually using pointers. And whereas these are not, these are using ordinary values, and these would probably be ordinary values, but over here you've got pointers. And it's the fact that it actually has sort of pre-matched which one goes to which one that makes traversing the connections that much faster. And if they had thought of it back then, they could have done it, but it wasn't their intent with SQL. And so the SQL standard was defined. That's the way relational works. It's great. But to really do graph analytics, you need a sort of a new architecture. And that's, I said, I think we've reached the end of the hour. As I said, this is recorded. So if you signed up, we'll be sending you a link to the recording shortly. And even if you didn't sign up, you can, in a few days later, you'll probably be able to go to our website or YouTube and eventually find it. So I said, this unfortunately is not yet available in TigerGraph Cloud, but there are a lot of other cool things on TigerGraph Cloud I would encourage you to go explore. You can download the product for free. You can learn more about the product through the community. You can get certification which will just educate you more about the G-SQL query language and TigerGraph in general. And I want to let you know that next week, next Wednesday, we'll have a Graph Gurus workshop. It'll be 90 minutes long. And we're talking 0 to advanced analytics, starting from nothing, no background. We'll show you how to get started with a graph database, analytics, and machine learning algorithms, all in 90 minutes. Rob and I thank you. Thank you for spending your valuable